Now let's look at the final question in the challenge and the second level difficulty C question called Hilbert Hiccup. Of course, this question is now intended to be the most complex question or the most challenging question in this particular series. So let's have a look. Hilbert's curve is a famous fractal design. Like most fractal programs, the code is recursive. This means it contains a function that calls itself while running. The function in this program calls itself several times. The program given below has a single numerical error in it. The task is to debug and fix the code to draw the required pattern. Now, before looking at the information, it's important to understand some of the important keywords that have been provided to us. The first one here is the fact that the word recursive is a complex computer science term, but it has been explained to you in this particular example because remember, we do not need to have coding experience to be able to access and do these challenges. All it means is that it contains a function that calls itself while running. So if we have a look here, here is a function called Hilbert, but there's Hilbert being called again. There's Hilbert being called again, another time and another time. That's simply all it means. So let's clarify that and understand that before we move on to the next part of the information. As usual, it says you can use the hide menu above to make more space. It says you can run the provided code to see what actually happens. It is a good idea to slide the speed to hair when you need to submit the answer, but this will be far too fast for debugging and the answer will not be submitted until it has finished running. So this is just telling us ways that we can debug the program in the best way possible using the features of the actual canvas provided. So things like the hair, the running, and obviously the next step. And obviously slowing down and speeding up this slider here allows us to check each step carefully and thus identify the error that we're already looking for in this task. Now, the final thing to recall is that there is a single numerical error. This means that we are looking only at the numerical values in this particular code. So that eliminates all the other values that are here, such as angle and level, because we don't need to change them. This is because they are not numerical values. So the only possible values that can be changed are numbers that are like this, where it's 0, -1, 25, 25, 15, etc. So we've familiarized ourselves with the code, the concepts in the code. The best thing now to do is do what the hint has told us. Let's run the code. Now I'm going to leave my slider at a sort of middle space, so it's not too fast and it's not too slow. And I'm just going to run it initially to sort of see what happens and what kind of pattern it's drawing. So I can see it started drawing a pattern, and the pattern does correctly follow the grey line. But as I can see on the third step, onwards, it doesn't correctly follow the line. So I can see that this is essentially the pattern being created and it is incorrect. So let's reset that, and now let's use the step function to run this one by one to actually see what happens each time the line of code is run, and of course to identify where the error is made. Now remember, when the code is run, the blocks highlight automatically to identify which section is being executed. So let's hide the menu to give us space to look at the code. Let's zoom out a little bit as well so that we can see all the code in one area. Now let's run the code, but this time let's use the next step function to allow us to draw the code correctly and slowly. So I can see that the first line has correctly been traced. Now if I continue clicking the next step, the next line has also been correctly drawn. So let's continue until I see that a line in particular hasn't been drawn correctly. So as I can see here, immediately I can notice that half the line has been drawn, but another part of the line is still remaining grey. Let's see if that gets completed in the next step or if it carries on. Now, if you've noticed a very subtle change here, the pointer is actually pointing this way. This means that my next step is actually going to draw a line in that direction. Now, as you can see, I've identified the error right here. The error is that the line doesn't actually go down the right amount of length and doesn't turn onto the correct grey line because it turns too early. So now let's have a look at exactly where we are in terms of the actual steps. So if I quickly press the next step to have a look at which part of my code is being highlighted, I can look at the numbers and identify that I'm moving forward. That is very clear to see. Now the first move forward, as highlighted here, is 25. The second move forward, which was correct, was 25. And then I noticed that on the third step, when I moved forward, I didn't quite move forward the right amount. Now I can see here an anomaly. The anomaly here is that the number isn't exactly the same as the first two numbers, which means that 15 is clearly a little bit too less than the 25 required. So let's change this to 25 and see if that actually works. So I'm just going to quickly run it at a medium speed again, so I can also watch my line being drawn at a relatively slow speed. But as you can see, immediately that black line has now correctly ended at the right amount of steps, and thus it has traced the grey line accurately. Now I can see that the first part of the pattern is successfully being followed. So in order for me to check if the entire thing is correctly followed, and as there is quite a lot of pattern to follow, let's speed up to the hair as suggested, and let's see if it actually completes the entire pattern correctly without any further errors, thus allowing us to check if our answer is correct. Well done. As you can see, the answer is correct, and this was actually, despite being quite a complex looking question and the final question in the challenge, a really straightforward modification if you broke down the problem slowly and looked at it step by step and debugged it using the slider function to make it go slower. So let's look at the show answer and explanation section and just check to see if our answer is correct. As you can see here, we did modify the correct number correctly. Clearly this is because the line being drawn was slightly too short and it should have been of the same length as the other two, again, thus being at 25. So as you can see in the explanation, it says that this is a debugging task. The key to these is to be systematic and run tests. So the first thing was to change the speed, which we did. Then it was to run the code watching carefully to see when the turtle goes off course, which we identified as being during the third step. Then it says to pause, go back a bit and use the next step button to see which moment it has a problem, which of course we did together. And it then says note that the code is highlighted in the workspace as it executes each block, which we also used as a very helpful feature, and that should help you spot the errant block which has move 15 instead of move 25. Increasing the speed of the turtle and running the program to the end confirms that the job is done, which of course we did because the pattern was quite large, and of course watching it rather slowly would have taken a lot of time to test the entire pattern to make sure that of course we check it quickly, correctly and efficiently. Well done for getting through all 10 challenges, and good luck for the Bebras coding challenge.